Hello, everyone. Welcome back. All right, so today we're going to be talking about solving rational equations. So let's talk about how we would approach solving something like this, where we have x's in the denominator. So, first things first, we need to figure out what could we multiply this by, all these terms by, in order to get something where we no longer have x in our denominator, or really any denominator at all, preferably. Well, I'm noticing that I have a denominator of x here, and a denominator of 3 here, and denominator of x here again. So if I multiply both sides by 3x, I think we can accomplish that goal. So let's do it. 3x times 2 over x plus 5 over 3 plus, we're not plus, sorry, equals 3x 7 over x. Awesome. Okay, so what's our next step here? Well, let's see. These x's are going to cancel, so we're just going to get 6 here. Plus, and then in this case, we're going to get the 3's are going to cancel. We're going to get 5x. And then over here, we're going to get 21x over x, which just cancels. So now we have 6 plus 5x equals 21. And that looks a lot easier, right? This looks like something you probably could have solved 3-4 years ago, right? So now let's just solve our regular linear equation. 5x is equal to 15, which means x is equal to 3. So therefore, x is equal to 3 is going to be our answer. Okay, now how would we solve something like this? Well, in this case, we're going to cross multiply. I'm going to multiply this up, and I'm going to multiply this up like that. So I'm going to end up with x plus 3, x plus 2 is equal to x minus 4, x minus 1. Now I'm going to expand these, and I'm going to get x squared plus 5x plus 6 is equal to x squared minus 5x plus 4. And then I'm going to put all of these on one side, okay? So therefore, 0 is going to be equal to x squared minus x squared minus 5x minus another 5x plus 4 minus 6. Well, the x squared and the x squared are going to cancel. And then we're going to have 5x minus 5x, which is negative 10x. And then we're going to have 4 minus 6, which is negative 2. Okay. Okay. So in this case, actually, we don't end up with a quadratic. In the end, we're going to end up with a linear. So I actually am going to put the 2 back on the other side and get negative 10x is equal to 2. And therefore, x is equal to negative 1/5. Or negative 0.2, whichever you prefer. Awesome. There we go. Okay. So then we have kind of a preview to the next question, which is a much simpler version of the same thing that's going to help us to kind of get the next one. It says, if Dave purchases 12 hats for $350, or $360, sorry, how much does each hat cost? Well, this is probably, again, this is probably something you could have answered in middle school or even before that, right? You'd say, well, if the total is $360 and he purchased 12 of them, then that means each hat would be $360 divided by 12, which is $30. So it costs $30 for one hat. And that's a great preview kind of into this next example. It says here, Ryan bought a case of concert t-shirts for $450. She kept 2 t-shirts for herself and sold the rest for $560, making a profit of $10 on each t-shirt. How many t-shirts were in the case? Well, let's think about that. The first thing I want to bring up is, what are they asking for? Well, they're asking for how many t-shirts were in the case. And what do we know, right? Well, we know how much profit she made on each shirt. We also know that she kept 2 for herself. And we also know the total amount that she spent on the shirts, right? And so for each shirt, we know that the revenue minus the cost is equal to the profit, right? And this is just a good general equation to know, right? The revenue, which is how much money we actually get in sales, or we actually get from our business, and then that's minus the cost is going to give us the profit, right? Because she had to spend money on these concert tickets. And this is similar to any business type question, right? Where we have, it's not like the business owner necessarily just makes all the money coming in, because they also have to pay the costs of running and operating the business in order to even get that money. And same thing here, where she bought the case of t-shirts for $450. And so she did have to spend money in order to make that revenue, right? If she had not spent that $450, she wouldn't be able to sell the t-shirts and therefore make the profit. Okay. So it says that she sold all of these for $560, right? $560 is how much she sold them for, right? And so in terms of that, it's going to be 560 over x minus 2, right? Why x minus 2? Because she kept 2 for herself, right? Okay. And then minus the cost, which the cost is 450 over x, right? Because she spent $460 or $450, sorry, on the t-shirts. And there were x t-shirts in the case, right? Actually, I should label my variables and say let x represent the number of t-shirts in the case. Okay, awesome. Okay, and what is that going to be equal to? Well, it says she made $10 in profit per shirt, so this is going to equal to $10. So that's our equation, and I think that's the hardest part for a lot of people is coming up with the equation to even start to solve this. The solving part's usually pretty okay because we already talked about how to solve something like this. So let's do it. Let's solve something like this. So first of all, to subtract, what do we need to do? We need the denominators to be the same in order to even subtract these. So to make the denominators the same, I'm going to multiply the first term by x over x. So we're going to have 560 x over x times x minus 2. And then over here, I'm going to multiply everything by what? By x minus 2. Oh, not minus 2, but x minus 2 in order to get the denominators the same. So that's the key, is to get the denominators the same, right? And at the end of the day, this is a technique we learned a very long time ago, right? Probably in elementary school, but we maybe haven't done it with variables as much, right? But just kind of think about, well, how can we make the denominators the same? By, multiplying by 1, essentially, multiplying by the same thing over the same thing to just be 1. Good. Okay. So next we have 560x. Oh, minus 450x plus 900 over x times x minus 2 is equal to 10. And then that means we have 110x. Oh, not 1110, just 110x plus 900 over x times x minus 2 is equal to 10. And then let's multiply up that x times x minus 2. So we're going to get 110x plus 900 equals 10x times x minus 2. And then let's expand that out. And we get 10x squared minus what? Minus 20x. Amazing. And then we're going to get 0 equals 10x squared minus 130x minus 900. And then we're going to factor out the 10. So we're going to get 10 times x squared minus 13x minus 90. And then we're going to factor this further. So we're just going to factor this quadratic. What are two things that add up to negative 13 and multiply out to negative 90? Well, I think 18, if we do negative 18 and 5, I think that should work. So let's do that. X plus 5, x minus 18, like that. And then we have x is equal to negative 5 and x is equal to 18. So we got two answers. However, it's not really possible for the amount of shirts to be a negative number, right? She can't have bought negative 5 shirts for $450. That doesn't make sense. So this one is not applicable. Okay, so therefore x equals 18 is the correct answer, and therefore she bought 18 shirts originally. So there we go. Awesome. All right, let's do one more example like this because I know word problems with like the rationals and reciprocal functions aren't everyone's favorite, but I do want to do a couple more examples to demonstrate this a little bit further. Let's do another preview though. It says here, if it takes Michaela 20 minutes to cut her lawn, how much of the lawn is completed after 1 minute? Well, 20 minutes to complete a full lawn, so that means after 1 minute, she's 5% done, or 1/20th of the way done. So therefore, 1/20th of the lawn is cut after 1 minute. And same with each minute, right? What if it was 10 minutes? Well, then 10 over 20, right? Half of the lawn would be completed. Okay. So let's move to example 4. It says, when they work together, Stuart and Lucy can deliver flyers to all the homes in their neighborhood in 42 minutes. When Lucy works alone, she can finish the deliveries in 13 minutes less time than when Stuart works alone. Determine their individual times. Okay, well, here's the thing. Let's talk about the amount of work done per minute. Okay, the amount of work done per minute. And let's let x represent the number of minutes that it takes Stuart, right? Because it's very close to, we don't actually have to do separate variables for these because Lucy would just be x minus 13, right? It says when Lucy works alone, she can finish in 13 minutes less. So she's 13 minutes faster. So if we know Stuart's individual time, all we need to do is subtract 13 from it and we will get Lucy's time. Okay? So basically, the Lucy's work in 1 minute plus Stuart's work in 1 minute is going to equal to the total done, the total work done in 1 minute, right? If they work together, there's obviously going to be more work done, right? So how much work can Lucy do in 1 minute? Well, it says that she can do 1 over x minus 13 in 1 minute, right? As for Stuart, it would just be 1 over x. And then the total work done in 1 minute would be 1 over 42, right? Because it says that when they work to deliver all the flyers together, then it takes 42 minutes. So the total work done in just 1 minute would be 1 over 42. And now we've got to solve this. So we've got to make the denominators the same as the first things first. So over here, I'm going to multiply everything by x, which is wonderful. And over here, I'm going to multiply everything by x minus 13. Okay. And then here we're going to have 2x minus 13 over x minus 13 equals 1 over 42. So there we go. Then I'm going to cross multiply this, and we're going to get 42 times 2x minus 13 equals x times x minus 13 over here. Now I'm going to expand. We're going to get 82x minus, let's see, what's 42 times 13? I'm not sure. let's see, 42 times 13. 546 is equal to x squared minus 13x. And therefore we have 0 equals x squared. And then 13x minus 82. That's going to be negative 95x plus 546. And that's pretty big. So you know what? Rather than trying to factor this, I'm going to just head straight for the quadratic formula. So the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a is what? Let's see. Or wait, did I make an error here? I did. I said this was 82. This should be 84. My apologies. Let's fix that. And that makes this 97. Okay. Okay. So 97 plus or minus the square root. What would be in our square root? Let's see. It'd be 9409 minus 2184 over 2, which is, let's see, 9409 minus 2184 is 7225. So 97 plus or minus root 7225 over 2, which is 85. So actually this would have factored nicely, it turns out, but 85 is such a large number, it may have taken us a while to get there. So therefore we would get, let's see, we'd either get 91 minutes or 6 minutes. Now the trouble is 6 minutes is too small, right? It says that when they do it together, it takes them 42 minutes. So it would not make any sense for, Stuart's individual time to be only 6 minutes at that same rate. So even though it's not a negative answer, this is still not applicable. So therefore, Stuart can deliver in 91 minutes, and Lucy can deliver in 13 less minutes, which would be 78 minutes. And I'll just put a quick thing here of 91 for Lucy. It'd just be 91 minus 13, which is 78. So I'll just put a quick thing there just to explain why it's 78. And Lucy can deliver in 78 minutes. Awesome. All right, well, that is it for today, everyone. Very good work, and I will see everybody next day for solving rational inequalities. Bye, everyone.